Today's webinar is how the Nephio Kubernetes framework can help us automate the network function deployment and also automate the infrastructure on which those network functions will be deployed. So I'll start with the agenda first. These are the things which we will cover. So we'll start by the new trends in the network automation and the challenges which are created by those trends. Then I'll talk about the limitations of the traditional network automation platform and the solution to it. And then we'll have a high level introduction of Nephio and how it tries to solve these challenges. Then we will have a little deep dive in Nephio. We'll talk about different components which are there in Nephio, different concepts of Nephio and an end-to-end flow. Then we will have a small demo where we will show an end-to-end orchestration of OI, core, and RAN. And at the end, we can take up the Q&A. Okay. So, today's, the trends in telco automation includes moving towards the cloud. We know that more and more network functions are being containerized, and we are, and today more and more network functions are moving towards cloud. And with this comes moving towards infrastructure as code. So with the maturity of cloud technologies and the rise of virtualization, there is a growth trend which we are seeing towards leveraging the public and private cloud platforms for hosting the telco cloud infrastructure. And also with the exponential growth of connecting devices, data consumption, and the rapid growth of bandwidth intensive applications, we are seeing that the traditional infrastructure is struggling to keep pace with the sheer volume of network demands. So with this, these are the challenges which are created due to the new trends which we are seeing. So traditional deployment, as we just talked about, is it's not able to keep pace with the new trends. And the traditional automation deployment is more of a monolithic and hardware specific deployment, and it's kind of fire and forget orchestration with their imperative network functions. So what we want is we want an intent-based orchestration and management. So rather than a complex process, admins and operators now want to declare a high-level intent, and the system underlying system should do the complex tasks. And also one of the challenges with the traditional system is that different layers operate on there are different automation control planes for different type of infrastructure, and different type of network function makes it impossible to provide interconnected automations. So here Nephio helps by giving the workload and infrastructure in a handling the workload and the underlying infrastructure in a unison manner. So it it operates on the end-to-end as we talked in the previous slides, right from the infrastructure and deploying the network functions on top of these infrastructure. Then we want CI/CD pipelines because of today's network functions, telco cloud and configurations are constantly changing. So it is important to ensure that the orchestration and management natively fit into the CI/CD environment. And of course, we want an orchestration platform which can handle the kind of scale which we are seeing today. The solution for this is the Kubernetes Nephio framework. So as this framework is Kubernetes based, it takes advantage of all the Kubernetes, all the Kubernetes features like active reconciliation, providing high level intents, and where user has to just express a very high level intent and declarative automation. So Nephio sets up the cloud and edge infrastructure and render the initial configurations for the network function, and then delivers those configuration to the right cluster to get the network up and running. Now I'll talk about different swim lanes which Nephio framework has. So Nephio basically operates on all the three swim lanes. first the infrastructure. So it helps to create the Kubernetes clusters and also bootstrap those clusters to make them ready to be consumed. And then the workload swim lane, which helps to deploy the network functions on the infra, which is created by the infrastructure swim lane. And finally, it finally the configuration, which focuses on the day and life cycle management of the network functions. With this, we'll talk about the high-level components of Nephio. So Nephio leverages some of the open source projects, which which is KPT Porch and config sync. KPT Porch has two controllers, package variant controller and package revision controller, and we will see how these controllers play in end-to-end Nephio orchestration. And config sync helps for the GitOps functionality, which is the core part of Nephio framework. Then there is Nephio core controllers. I'll briefly talk about all the controllers. Cluster API controller helps to create the clusters, and Bootstrap controller helps to bootstrap those clusters to make it GitOps ready. And then generic specializer controller helps in condition choreography, which we'll see in the upcoming slides. Then IPAM specializer and NAT controllers are for allocating IP addresses and network attachment definitions. Then repository controller helps to set up the repositories, and package approver controller helps to approve the packages. So KPT has a notion of having different stages of packages: draft, propose, etc. So this basically helps in automation of that part. Now we will look into some of the key concepts in Nephio framework, which is config injection, package specialization, and condition choreography. So config injection, basically it's a process of injecting the contextual information in the downstream packages. So the KPT functions, they actually, some of the KPT functions require some contextual information to operate on, and they basically tell the controller which exact configuration is required by adding this annotation called config injection required is equal to true. So whenever the controller see this, it will look into the in-cluster objects. In this example, that in-cluster object is workload cluster, and it will inject that cluster in the downstream packages. So that information basically is used or consumed by the KPT functions to perform their tasks. One of the examples is allocating the IP addresses. So to allocate the IP addresses, the controller needs to know about the contextual information or the workload cluster. So this workload cluster basically is an in-cluster object which is already created, and it contains the information about network attachment, network CNIs which the target cluster has. So based on that, the KPT functions can perform their tasks. So we will look at see how it works in detail in when we look at the demo. Yeah, so this is basically what I just talked about. So the source of configuration, as I told, that it's an in-cluster object, and the slides talks about the workload cluster, which contains the contextual information. Then comes the specialization, pipeline, and condition choreography, which is another main concept of Nephio. So a pipeline basically is a set of functions, KPT functions, which are defined in the KPT file in the upstream packages. So these functions, they have two kind of properties, which basically owns and watch. So these functions owns certain, certain resources, and it watches for certain resources. So watches basically provides the dependency. Basically, it is for having the dependency. So one KPT function can be dependent on the other KPT function. So in this way, it tells the controller the exact resource on which it depends on. And the generic specializer controller, looks into all these conditions, and based on the conditions, it calls the corresponding KPT function. And when the KPT function performs a task, it basically
is that plan, right? Yeah, correct. And like I said, that may be split half
sorry,
time
I think
across
someone
two
needs to go
individuals.
on mute. Yeah. So once the KPT function performs a task, it will mark the status as ready. So it will start by all the statuses will start by not ready, and one by one, the status starts becoming ready. And whenever we save package revision, it triggers the pipeline. So this way, eventually, all the resources are allocated and all the conditions in the KPT file are set to ready by the condition choreography, which are done, which is done by the KRM functions and controllers. And the result is a final curated CR in the target cluster. Yeah. So now we'll talk about the infrastructure automation flow. So basically, package variant controller, clones the upstream package. So we have a management repo which contains the upstream, which contains the packages for creating the infrastructure. And because the target cluster is not ready yet for GitOps, these packages or these upstream packages are cloned to the cluster management repo. So once these are cloned to the cluster management repo, the config sync basically kicks in, and then we have different controllers, for example, cluster API controller, which will create those resources. Now, those resources are essentially the kind clusters, and then we will also have the repositories which are set for those kind clusters. And the bootstrap controller basically, create the root sync in the target clusters and set the secrets and all, so that the target cluster is able to connect to its repository. So this is an overview of the infrastructure automation flow. So once the infrastructure is set, we can consume it for the next flow, which is the workload deployment automation. So again, package variant is what package variant basically clones the packages from the upstream repo, and it pushes the packages downstream repo, or which is in this case the edge repo of the cluster on which the resources needs to be deployed. And in between, the KPT functions and condition pipeline, which we just saw, plays, and the final packages which are pushed to edge repo are mutated and hydrated. And again, here in this slide, we are talking about the conditions which we talked about in the previous slides, and the specializers which handle those conditions. And then there is the approver controller, which approves the resources, the package variant resources. Now we can look into or we can have a demo which is essentially orchestrating OAI, core, and RAN. This is the eye-level test setup. So we will have three edge clusters, or three clusters, basically workload clusters. One is for core, one is edge, and one is regional. And we will deploy core components, RAN components, and the operators for them. We'll start by setting up the networks between them, which is for now it is a manual process, but in future that process will also be automated. So once the networking is set, then we will deploy the dependencies, which is basically my database, and then operators, different operators, OAI operators, and then at the end we will deploy the network functions, and we'll see the ping test to ensure that everything is set up. So this is the network diagram, high level network diagram for a typical 5G deployment. Now I can just go to the demo. Here we are seeing the repositories which are registered. So we see that there are different catalog repositories. So these are the upstream repositories which contains the different packages. Essentially the packages for creating the edge clusters and packages for deploying the network functions. And then we have management staging repository, which helps to create the clusters and then bootstrap the clusters. And then we have, of course, the management repository. So we'll start by creating, the three clusters which we just saw. So to create these clusters, we will apply a YAML file which has the package variants. This is how a package variant YAML file looks. It will have an upstream and it will have a downstream. So in this case, upstream is same for all three deployments, because we are essentially creating the infrastructure, which is nothing but the clusters. And then we have different downstream. Now, once this is applied, we see three package variants created, and these three now the controllers will kick in, and then it will start deploying or start creating the clusters. Here we can see that there are three clusters which are created, which is essentially these clusters which we talked about: core, edge, and regional. Yeah, so it is little, the image is little clipped, but these are core, edge, and regional clusters. Once the clusters are created, then there are some scripts which we run for creating the networks. So as I told, there are manual steps for now for creating the networks. So essentially what we are doing is, we are using we essentially want the inter-network connectivity, right? So for that, we are setting up the networking using container lab tool. And once the networking is set, we will be adding some configuration for node VLANs, etc. So I'll quickly skip through all that process. So here we are using some Nokia operator for the connectivity. And in the production environment, this might be replaced by the specific specific CNI or specific networking which an organization is using. Once the network is set up, we will deploy the dependency resources. We'll start by deploying the database, and then we will start deploying the operators. So these are the operators which are deployed in different clusters. And again, these operators are deployed, these dependencies are deployed by creating the package variant. So package variant and package variant sets, basically package variant sets is nothing but it in package variant set, we can provide multiple targets in one go, and in return it will create package variants for each of those targets. Yeah, so once these dependencies are created or dependencies are deployed, then we will we will deploy different network functions, which is essentially core and RAN network functions. So I'll quickly forward through this. Yeah, so these are here we are deploying the different network functions. Here we are deploying the core network function. Yeah. Now, if we look at the package revision resource of SMF, we see that there is a workload cluster which is injected by the controller. So this is what we discussed in the previous slides, which is essentially the config injection. So this whole workload cluster is injected in the downstream packages or package revisions. And then we will see the different conditions which initially all the conditions will be not ready, and eventually those conditions will become ready. So these are the conditions. Actually, I fast forwarded this. So initially the conditions were not ready, and finally we can see that these are the conditions which are becoming ready one by one. Yeah. So you see that these are the status and the conditions. So once all the conditions are ready, the package revisions move from draft to proposed state, and then the controller approves them. And once the controller approves them, it will be config sync kicks in, and it will deploy the resources on the target cluster. Uh, yeah. So yeah. So once all the different network functions are deployed, yeah, here actually we are seeing the different status are. I mean, the status starts with false, and then eventually they are converted to true. Yeah, now we are just looking at the RAN component, which is up and running now. Then we are deploying the UE, and once the UE is deployed, we can do a quick ping test to ensure that everything is deployed properly and set up. Yeah, this is the ping test. So this was the quick demo. Now we can move on to Q&A. Yeah.
A few questions.
Yeah.
So could you please show that slide in the PPT where like each component has one controller associated with it?
Each component has one controller.
Of each component of the core network has one controller associated with it.
Not sure which slide you're talking about.
There's
Maybe I'll start with. Are you talking about this?
next.
When you present the demo, I think when it's
Next.
It is the last slide.
next.
Second last slide, Vikas.
This one.
This one. So my question is, so basically, these controllers for each component in core network, is this part of the Nephio or like someone else made it separately on the outside?
It is the part of Nephio actually. That's what essentially the R2 release is about. So in R1 release, Nephio gave the support for free 5GC, and in R2 release they gave the support for OAI. So these controllers are from Nephio itself.
Okay, so basically my question is, so like I've used OAI core network. So like if instead of me as human being going to like say smf.yaml, making like some configuration changes, so this controller would do that instead of like a human being. Is that the purpose of this like OAI AMF controller, SMF controller?
Exactly, yeah. So these are kind of wrappers on top
Okay.
of that. Yeah.
Yeah.
Okay.
Not exactly. I just if I can add a few words about it. For me, so this controller are using some specific customer resource defined by Nephio.
Yeah.
That has been populated dynamically using the KRM function on fetching the right value, fetching the right IP address, and so on, and to populate all the configuration file. And then once that is defined, it will populate the custom resource that will be consumed by the controller, IMF controller. On this controller, let's say, will translate this custom resource into various Kubernetes objects, typically a deployment, replica set, and so on. So there is two parts in Nephio. We have these operators, controller, that are using custom resource on CRD defined by Nephio, and then with a high level abstraction to define the network function, and then deploy the various Kubernetes objects. But meanwhile, there is also this injection on the specialization function as presented previously. That is, let's say, dynamically populate the custom resource with the right value depending on the context where you deploy the function. This is a great value.
Yep.
Thank you.
Hey, Vikas, thanks for the good demo. This is Abhishek here. A quick question on the operators as such, right? What is exactly Nephio's deliverable? Because the operators and the CRDs that are gonna be developed by the network function supplier. So what is exactly the Nephio community is delivering? Which would help the operators to the service providers to basically say, hey, I want to deploy UPF, right? You started with the intent-based concept, okay? So we understand you're gonna model some of your policies in the form of an intent. Good. But majority of the development, in terms of the operators or in terms of defining the custom resources file, are actually owned by the network function suppliers, right? Like be the vendors like Ericsson, Nokia, and so on, right? Now, thing is, what exactly is Nephio contributing, or which all the network function suppliers can take some guidance and then augment their functions? Can you touch upon that, please?
I can answer that. So that is exactly what Eric was explaining, right? So what is required is, yeah, I mean, the vendors have to create controllers, but the whole creation of the custom resource based on the context and based on the environment in your target cluster, automation of that, basically creating all these configuration dynamically and setting up the network attachment definitions based on the CNIs that are there, etc. So that is what Nephio gives. So that is the framework. So the core controllers which interface with Git, which is the porch, and then there are several specialization controllers which exactly know how to create network related configurations, for example, and the whole network deployment CR, which is actually the CR for the OAI operator, for example. So all that is generated dynamically. So that is what Nephio gives. I mean, that is the core of it. And what it requires is, yes, the resource that it is creating has to have a Kubernetes API, which is the via the controller that you have.
No,
So
correct,
there was
correct.
one slide where Vikas showed the components of Nephio.
Yes.
So I can name them primarily. Yeah, I mean, if you see, I mean, there is a controller for cluster bootstrapping itself, and then there are several specializers like this, which specialize in generating the configuration of your network function dynamically. And then Nephio is also creating an SDK using which you could create specializers on for your use case, controllers for your use case. So that will be the value.
So thanks, Gurpreet. So from my perspective, what I was looking at is like, say, when we talk about the operator based or operator assisted lifecycle management, two things comes into picture: APIs and the information model or the data model, right? So is Nephio going to standardize the data models around CRDs and the operator, or it gives entire flexibility to the suppliers that they can create their own CRDs and operators and integrate with the Nephio framework, and it will be done, right? Because the CRDs and the CRs, who gonna be dictating the standards and the normalization around that?
That is difficult. I don't think that creating any standardization around the CRDs for every vendor, I doubt that will be the direction. But how to, yeah.
Yeah, maybe I can add a few words because I'm involved in Nephio community. So what we are intending to do in Nephio, so we try to define quite standard CRDs to define network function. So today, for example, we have one generic CRD to model network function. It's very high level. We have some specific fields with capacity, interfaces, parameter ref, and so on. And also what we did in release 2, we also tried to, let's say, standardize the way the configuration should be defined based on the 3GPP specification, for example. So this is also an effort led by Nephio to try, let's say, to push a common way, let's say, to model the various configuration based on Kubernetes. So this is an effort, ongoing effort, started in RIS 2 to try, let's say, to have this standardization way to for the configuration part. But it's just started in RIS 2. We will continue in the next release. But also, like that, we hope that the various vendor will use the same, let's say, the same custom resource definition for the network config part. On that result, it will facilitate the, let's say, the work for the telco service provider.
Got it. Thanks, Eric. That gives some context.
I have a question for that as well. Is that standardization dictated by Nephio or by KPT? Because I suppose it's KPT that is going to manage the configurations provided in the upstream repository. Am I right?
KPT is a packaging format, and KPT allows you to basically automate the generation of configurations, and it is not specific to any standard or any telco application. You can basically package any Kubernetes application as KPT and have the pipelines in your KPT packages to automate generation of the configuration. So it will not be
Okay, I
KPT.
understand.
So yeah.
Thank you.
I have one more question. As KPT is the OG tool for Nephio framework, right? But most of these suppliers or say service providers are receiving network functions that are in the format of Helm packages and so on, right? So is Nephio advertising that, if you want to use this intent-driven paradigm of orchestration, use KPT as the directional packaging tool?
Yeah, I
So
think
that
KPT
work is in progress, and basically making Helm as first-class citizen. So that work is in progress, and there have been some POC which is already done, and it is available in the Nephio Git repo also.
Yeah.
Using Helm underneath Nephio. Yeah. Custom
so
resource definition, CRDs.
So
Sorry, there was.
KPT and Helm gonna complement each other, or it is competing with each other? Gurpreet, can you say
I'm
that, right?
Sandeep. I don't know why
Sandeep.
the name is Gurpreet there. I'm Sandeep.
Okay.
Yeah, so KPT and Helm are two different ways of packaging your KRM files. I mean, they will. I don't think they will complement each other.
Okay. Thanks, Sandeep.
Thanks.
I would like to ask if this Nephio is like a competitor to HC, OSM, ONAP, or can it be integrated with them?
Maybe ONAP can be used above Nephio. I mean, Nephio does not have as such the orchestration layer as such. So if you see the initial slides of Nephio, the first architecture diagram, so there is a layer on top of Nephio. The ONAP can be placed maybe there.
Okay, so Nephio would be like, so basically Nephio would be in like the MEC layer of your telecom network, and you could have like ONAP for the orchestration layer of the telecom network.
Yes.
Maybe.
Okay, understood. Thank you.
Yeah, and one more question, especially in the case of end-to-end automation aspects, because we know that when we deploy any network function in a network, right, there are certain steps that includes lifecycle management, and there are certain steps that includes configuration management, right? So which means that you have to run some bunch of CLI commands and so that to configure network devices. is Nephio also coming up with an automation framework, which there are 10 steps to deploy a network function, out of which 5 steps can be done within the domain of Kubernetes, and for remaining 5 steps, which cannot be done performed with the domain of Kubernetes controllers, there would be some additional workflow engines that will take care of the end-to-end automation. Right? Is Nephio heading in that direction or out of scope of Nephio's project?
I believe it will, I mean, it has to be a Kubernetes API. If you have to configure your network function, you are creating a controller for that. And that is the interface. I mean, custom resource is the interface of all the configuration.
Custom resource. Okay. So for example, in custom resource definitions, you would add. Okay. Yeah, I think then that is more on the network function supplier, that his application is more evolving towards like a more cloud native application, right? There is no actions needed besides the Kubernetes operation to configure the device.
Yeah. And then if you have interfaces like netconf, for example, there are netconf controllers, or you could write a controller which supports netconf in the southbound. But
And
yeah,
typically, just for example, it was not demonstrated during the demo, but for all the networking part, there is a controller, a Kubernetes controller that configure the router, virtual router devices, device using netconf interface, and this is done via a specific controller, Kubernetes controller.
yes.
Right. I mean, we have come across situations where where we have seen some of like the suppliers support SSH based mechanism to configure your network function. Those are typically outside the context of the CRDs or the custom resources, or say even the API based paradigm. So I don't think we can do anything. I mean, Nephio is not going to do anything about that, right? Because the application is pretty legacy sort of thing, and Nephio cannot do anything in terms of workflow automation, right?
Yes and no.
You can use Ansible based operator. I mean,
Yeah, but I think yes. In Nephio, I don't. We have what we call three swim lanes. So the first one is to deploy and manage Kubernetes clusters. Second one is to deploy a network function, and the third one is really to configure network function. And if you can model the way to configure your network function using Kubernetes CRD, you can develop an operator that will take as input your custom resource, and then we translate that towards, let's say, the protocol used by your network function. That's the possibility. But at the end, the stretch goal is really to have, let's say, network function fully compatible with Kubernetes capability, with, let's say, for example, config map basic native configuration, and as a result, it will be easier to develop the controller.
yeah. So basically, I mean, you have to have a Kubernetes API, and yeah, your SSH example, I was saying, it's pretty straightforward to write an Ansible based controller using which you can do SSH and configurations. I mean, that is just for your example that you took.
No, yeah, I understand, Sandeep. Yeah, that's a bad example I gave, but unfortunately, that's the reality. Yeah, so basically, there's an evolution needed in the application function itself to support a Nephio-based paradigm of orchestration.
It's a cloud native platform, so yeah, it has to be
Right.
Kubernetes API.
Sense. And what exactly would be the role of KPT? Because you briefly touch about that, like say, if a network function supplier has to pivot to a Nephio-based paradigm, right? What exactly would be your guidance to the suppliers, right? What he can make use of KPT tool to perform, or what would their benefits they're gonna get out of that?
Benefit to get out of the KPT function itself?
Yeah, that's right. Like say, for example, you mentioned it's a packaging tool, right? Which contains some bits and pieces of custom resource definitions to deploy XYZ microservices. And once the microservices are up and not, right, there would be some sort of boot order dependencies that, do task step B, C, D, and so on. So what exactly KPT is going to do that, in terms of stitching those, telco dependencies and stuff like that. I mean, I am assuming KPT is more of an envelope. In that envelope, you are adding more Helm charts, or maybe, sorry, the custom resource files, the KRM models, and so on. But if an application, complex application is composed of, say, 200 microservices, there will be some amount of boot order dependencies and stuff like that, right? That, execute or install microservice A first, then do some configuration, then install microservice B, and so on, right? Like a classic example, if I were to give, you are trying to install a relational database. Once the database is created, you want to create a table, databases, and so on, right? And then you would go and install the other middleware application that will connect with database, sort of a thing, right? A typical example. So what would be KPT's role in that,
Yeah, KPT, I think as Sandeep told, right, it's just a packaging format.
So
No. I think no. Yeah,
so
yeah.
KPT is, I mean, that is exactly what KPT is for, the way you are describing the problem. So KPT gives you the ability to create pipelines, define the dependencies, and then in that order or in whichever order, the functions that specify in the KPT file starts acting on the configurations, and that is how the dependencies are resolved statically. I mean, let's say application A depends on application B. It is to create, I mean, application A, B is waiting for some configuration or some resource to be allocated, which only application A can generate. For example, in this case, there are different functions, right? IP claim, the network attachment definition, etc. So these KPT functions internally invoke the controllers. KPT function can only, I mean, generate and manipulate KRM resources. And then with the help of the specific network controllers, it can allocate the resources as well. I mean, for example, in this case, the whole IPAM or IP address allocation. So that is done via a controller, but that controller is driven by a KPT function inside. That is part of a KPT pipeline, which is watching that this resource gets allocated. And once it gets allocated, it will mark certain conditions as true. And that true is looked upon by other functions in the pipeline. And that's how, if you create a pipeline like this, the all the KRM functions, they will basically work together and yeah, I mean, resolve the dependencies. And eventually everything, once only everything becomes true, you have your final configuration. And in that, in this whole specialization pipeline, condition choreography, all those uh, all that automation is there, and that is how it is getting resolved. So KPT is meant for that.
got
So
it.
yeah,
So
Eric, you could please.
it's just not a packaging tool. It's even more than that, right?
No, no,
Because
it's way more than that. In this drawing, these yellow boxes, uh, these are functions. Blue boxes are controllers. They all work in conjunction. And what Nephio gives is, as I was saying, I mean, there is an SDK which using which you will be able to actually, for KPT there is already SDK. It is called KPT library. It is there in Nephio repo. I mean, you can create KPT functions based on the requirement of your service, your network functions. So that is what, yeah, KPT. It is not just packaging, not just Helm like packaging format, packaging tool.
got it. Got it. Thanks, Sandeep.
Yeah. Is there a manager that coordinates downstream agents that reconciles resource? Yes. So that, if that would be the config. So Alexis has this question. Can you please review the GitOps part? Is there a manager that coordinates downstream agents that reconcile resources at the edge, and how are those resources? How are the source of truth? So that tool in Nephio is config sync, which is basically continuously reconciling the configuration that is in its Git repo to the release or to the version that you configure in the config sync. Yeah, so that is the answer. Thanks.
And this config project is under CNCF umbrella or LFN Foundation?
Config sync
Or
is
is
not
it-
in not
No,
in
it's,
the CN,
it's,
it's not in LFN.
it's under Google. It's a Google open source.
Yeah, exactly.
Google? Okay. Okay.
Yeah. Yeah.
Okay, guys. Thanks a lot for the rather engaging discussions that we have had thus far. Vikas, thank you very much for taking us through the presentation and the valuable inputs you had to share with us. For any further questions, the email ID is mentioned on your screen. Feel free to reach out to us by dropping a message on the email that you can see. You can also keep Vikas in CC, and we will respond to all your emails, queries, questions that you have in a timely fashion. Thank you, everybody. And it was a very interactive, rather engaging session. And we shall see you really soon on our next webinar. Please keep an eye on your inbox. You should be hearing from us really soon on the next webinar. Thank you and have a good day. Bye-bye.
Bye.
Thank you.